Recently, Elon Musk and NASA have shared some fascinating insights into their current achievements, ambitious future objectives, and the detailed roadmap guiding their journey. From the development of the revolutionary Starship spacecraft to the intricate plans for orbital refueling, this disclosure highlights the significant strides SpaceX is making towards achieving full and rapid reusability of spacecraft. Join us as we delve into these revelations and explore the exciting developments that lie ahead for SpaceX and its mission to make life multiplanetary. Before SpaceX can embark on its historic mission to the moon and Mars, several critical steps need to be taken to ensure the success and sustainability of these endeavors. These steps are not merely technical challenges, but are pivotal in setting the stage for humanity's leap into deep space exploration. The immediate focus is on enhancing capabilities of the Starship spacecraft, refining reusability techniques, and mastering orbital refueling technologies. In a recent announcement, Elon Musk and NASA provided a comprehensive update on their collaborative efforts and progress made so far. They highlighted significant achievements such as the successful demonstration of cryogenic fuel transfer during Starship's Flight 3, a key milestone in orbital refueling technology. Additionally, they laid out a clear roadmap for the upcoming missions, emphasizing the necessity of achieving full and rapid reusability of both the booster and the Starship itself. The roadmap includes ambitious plans for a series of test flights aimed at perfecting these technologies, ultimately leading to manned missions to the moon and beyond. The evolution of the Starship spacecraft is central to SpaceX's mission. And in the coming years, we can expect significant advancements in its design and functionality. The Starship is being developed to be fully reusable, which involves in perfecting the ability to land both the booster and the spacecraft safely back on Earth. This reusability is crucial for reducing the cost and increasing the frequency of space missions. Moreover, the capability of orbital refueling will enable the Starship to carry out longer missions, including those on Mars. As Elon Musk has emphasized, achieving these goals by the end of next year is not just a target, but a necessity for the ambitious timeline set for missions like Artemis 3 in 2026 and future Mars missions. Flight 4 marks a pivotal moment in SpaceX's journey toward making space travel more sustainable and accessible. This upcoming flight is not just another test, but a critical step in demonstrating the feasibility of landing and reusing spacecraft components, a concept that would revolutionize space travel. The success of Flight 4 will validate years of research and development, providing that SpaceX's innovative technologies are not just theoretical, but are also practical and reliable. This flight is set to usher in a new era of Starship, characterized by cost efficiency and increased launch frequency, both of which are essential for long term space exploration and colonization. Landing and reusability. One of the most groundbreaking aspects of SpaceX's approach is the concept of landing and reusing stages of the spacecraft Starship. Traditionally, rockets are expendable, meaning they are discarded after a single use, leading to high costs and inefficiencies. SpaceX aims to change this paradigm by developing rockets that can be reused multiple times. The idea is to land the booster, the first stage of the rocket, back on Earth using a virtual tower system. This innovative method involves advanced navigation and control systems that guide the booster back to a designated landing site, allowing it to be refurbished and launched again. Achieving this will significantly reduce launch costs and make space missions more economically viable. SpaceX has set several ambitious goals aside to achieve this by the end of next year. The primary objectives include the full and rapid reusability of both the Starship booster and the spacecraft itself, as well as enabling orbital refilling of the spacecraft. Full reusability means that both the booster and the Starship can be launched, landed, and relaunched multiple times with minimal refurbishment. This is crucial for reducing costs and increasing the frequency of launches. Orbital refilling, on the other hand, allows the spacecraft to replenish its fuel supply while in orbit, enabling it to travel further and stay in space longer. These capabilities are essential for missions to the moon, Mars, and beyond, as they ensure that the spacecraft can carry enough fuel and supplies for extended journeys. Achieving these goals by the end of next year is critical for SpaceX's long term vision of making life multiplanetary. The timeline is driven by several factors, including upcoming missions like Artemis 3, scheduled for 2026, which aims to return humans to the moon. Meaning the deadline will ensure that SpaceX has sufficient time to refine its technologies and conduct additional tests and address any challenges that may arise. This proactive approach will help SpaceX stay on track with NASA's schedule and its own ambitious plans for Mars missions. The success of these milestones will also demonstrate the feasibility of sustained human presence on other planets, paving the way for future exploration and colonization. The plan for Flight 4 includes the groundbreaking attempt to land the booster using a virtual tower system. This involves a highly precise and automated process where the booster will be guided back to Earth, aiming for a pinpoint landing on a designated platform. The success of this landing will be a major milestone, proving that SpaceX can reliably reuse its rockets. This method, if successful, will reduce the cost of space travel and increase the frequency of launches, making it feasible to conduct regular missions to the Moon, Mars, and other destinations. The implications of a successful Flight 4 are profound for future missions. For instance, the ability to land and reuse the booster will be crucial for Artemis 3 mission in 2026, which aims to establish a sustainable human presence on the Moon. Reusability will also ensure that SpaceX can provide consistent and affordable transportation to the lunar surface. Moreover, the success of this flight will lay the groundwork for Mars missions. By demonstrating that spacecraft components can be reused and refueled in orbit, SpaceX will prove that long duration missions to Mars are feasible. These adjustments will not only advance and support NASA's goals, but also accelerate SpaceX's vision of creating a multiplanetary society, bringing humanity one step closer to exploring and inhabiting other worlds. Achieving full and rapid reusability of both the booster and the Starship spacecraft is a complex and multifaceted goal that involves several critical steps. First, SpaceX must conduct numerous test flights to validate the reusability of technologies under real-world conditions. These flights are designed to gather data and refine the processes required for safe and efficient reuse. The iterative testing approach allows SpaceX to incrementally improve their systems, addressing any issues that arise and optimizing performance. Each successful test brings them closer to their goal of making space travel more sustainable and cost-effective. The plans for reusability are centered around innovative landing and recovery techniques. For the booster, SpaceX intends to use the Mechazilla arm, a towering structure equipped with mechanical arms designed to catch the descending booster. This method aims to provide a precise and controlled recovery, minimizing damage and turnaround time between launches. The ship, on the other hand, will initially undergo splashdown tests, where it will land in the ocean to evaluate its structural integrity and also recovery process. These splashdown tests are critical for understanding the dynamics of re-entry and landing, paving the way for future attempts to catch the ship using the Mechazilla arm. Successfully implementing these techniques will significantly reduce the cost and resources required for each mission, making frequent and rapid launches feasible. Refueling missions play a pivotal role in enabling space travel, as they allow spacecraft to replenish their fuel supplies while in orbit. This capability is essential for missions that venture beyond low Earth orbit, such as those to the Moon, Mars, and potentially even further into the solar system. By refueling in space, spacecraft can carry additional payloads instead of extra fuel, enhancing their operational efficiency and range. This technological advancement is a massive cornerstone of SpaceX's strategy to support long duration missions and establish a sustainable human presence on other planets. A significant milestone in this endeavor was the tipping point mission, which took place during the third flight of the Starship. This mission successfully demonstrated the transfer of cryogenic propellants between tanks in space, a critical step in proving the feasibility of orbital refueling. The ability to transfer cryogenic fuels, which are essential for rocket propulsion, validates the engineering and operational concepts required for in space travel. This success not only showcased the technical capabilities of Starship, but also underscored the potential for future missions to leverage this technology for extended space exploration. Building on the success of the tipping point mission, the next steps involve the development of specialized hardware for propellant transfer. This includes the construction and testing of docking mechanisms, relative navigation sensors, quick disconnects, and hot gas thrusters. These components are crucial for ensuring the two spacecraft can safely and efficiently dock in orbit to transfer fuel. SpaceX plans to conduct these developments throughout 2024, with a focus on refining the technology and preparing for operational deployment. By 2025, the plans to demonstrate ship-to-ship fuel transfer in orbit, which will involve launching two Starships, orchestrating a rendezvous, and performing the refueling operation. This ambitious goal, if achieved, will mark a significant leap forward in space travel capabilities, enabling missions that can venture further and last longer than ever before. In the second half of 25, SpaceX is gearing up for a significant milestone, the uncrewed Starship HLS, or Human Landing System, demo mission. This mission represents a crucial step in the development of spacecraft capable of carrying astronauts to the Moon and beyond. Preparation for this demo mission involves extensive testing and validation of the spacecraft system, including propulsion, navigation, and life support. SpaceX engineers will also conduct rigorous simulations and ground tests to ensure the safety and reliability of the vehicles before launch. The success of this mission will demonstrate SpaceX's capability to deliver payloads to the lunar surface and pave the way for crewed missions for the future. Achieving milestones ahead of schedules, such as the successful completion of the uncrewed Starship HLS demo mission, will have significant implications for the Artemis 3 mission and SpaceX's broader goals. Artemis 3, scheduled for 2026, aims to return humans to the moon and establish a sustainable lunar presence. By demonstrating the capabilities of the spacecraft, SpaceX can also position itself as a key partner in NASA's Artemis program, providing reliable transportation for astronauts and cargo to the lunar surface. Moreover, early success in the development and testing of Starship enhances SpaceX's credibility and reputation in the space industry, opening up opportunities for future collaborations and commercial ventures.